fellow Earthlings and explorers of all ages, and welcome to Ask An Astrobiologist, the show that celebrates the science and the scientists involved in our quest to understand the nature of life. As usual, I'm your host, Dr. Graham Lau, also known online as the Cosmobiologist, and we're brought to you by the NASA Astrobiology Program and SegaNet.org. As always, I want to send a huge thanks out there to all of you who are engaging live in the YouTube chat. I see lots of wonderful comments coming in. To those who are sharing about our show on Instagram and X and Facebook and LinkedIn and TikTok and all the different social media places, thank you so much. This month, a special shout out to the user at AstroBioBuzz on X for sharing about our show. I don't know who this person is. I haven't met them, I think, in person, but I should go wherever they are and buy them a cup of tea or coffee or their favorite beverage because they've been sharing about our show a lot, engaging with our guests, and I really appreciate that. So thank you very much to all of you for tuning in. Now, today's episode is going to be a romp through a lot of topics related to astrobiology and alien civilizations, the future of our civilization, the search for techno signatures, and more. Joining me today is Dr. Adam Frank. Dr. Frank earned his undergraduate degree in physics from the University of Colorado Boulder, close to where I'm at, as well as his master's and doctoral degrees in physics from the University of Washington. In his main research after that, he was focused kind of in the realm of the evolution of stars, their birth, their life, their fates. But he's also done a lot of work, not in just publishing lots and lots of scientific articles. He's also written a lot about a myriad of topics in science fiction and science and culture in a lot of different ways. He's been interviewed for many different kinds of newscasts and television shows. He was the science advisor for the Marvel movie Doctor Strange. And among the books he's written is his newest book, The Little Book of Aliens, which I was very excited to read this past weekend on a flight. It's a fantastic read. We're going to talk about that book a lot here in the time we have together. Dr. Frank is now a leading expert in the world in techno signature research, as well as in conceptual ideas in astrobiology. So, Adam, thank you so much for joining me for Ask An Astrobiologist.
Thank you, Graham. It's a real pleasure. I love the work you guys do, so it's a real honor to be here.
Oh, well, thank you so much. Yeah, at SegaNet.org and the NASA Astrobiology Program, we're doing a lot, not just to fund and support a lot of astrobiology research, but also to share all of the cool things going on across the world, across the community in astrobiology. Now, before we get started talking about your book and your work, one thing I love for all of our guests to share is their origin story. What turned them into a science superhero? What really got you into science in the first place?
It was getting bitten by that radioactive spider. No, it was my dad's. When I was 5 years old, I have this very clear memory of going into my dad's library. He was a writer, and I'm 5 years old, so it was the lowest shelf. Finding his pulp science fiction magazine, so Isaac Asimov's Astounding Stories and others, and on each one of those magazines, there was a cover, an illustration, kind of lurid, of either people bouncing around on an alien planet in Michelin tire spacesuits, or I remember one of like a guy. It was a rocket that was, the rocket was on and somebody had fallen into the exhaust and was getting, fried. And I was like, ah. But then there was also the bug-eyed monsters, the alien monsters. So that is what launched my career in astronomy, my interest in astronomy. And from 5 years old on, there was nothing else. There was nothing else I wanted to do or could imagine myself doing. And my dad was really cool that he was interested in science, and he would take me and my sister to the Museum of Natural History in New York, the Hayden Planetarium. Many, many trips. My sister was like, "Oh God, do we have to go there again?" And that really fueled my my knowledge and my understanding. And so that was where it began. And all through high school, I read huge amounts of science fiction. I listened to Star Trek or watched Star Trek reruns back there in the 70s. Religiously every day, twice a day. There were 2 channels that they had reruns. So science fiction played a big role also in shaping my scientific career.
Very cool. Yeah, I think, science fiction, dinosaurs, aliens, a lot of these main themes I hear from a lot of our guests, the things that inspired them and got them interested very early on. Now, your research through undergrad, grad school, and kind of afterward was really focused more in the astrophysics, kind of hard astrophysics realm, understanding the fates of stars and their evolution. What do you think kind of drove you into doing research on stellar evolution?
Well, what happened was, as often happens, I think, with people in graduate school, is you get there, you're interested in something astro. I was actually a theoretical physicist. I mean, I was in the physics department at the University of Washington. And so you just look around for people to work with and who's got funding, right? That's often it's a bit of an accident who actually has a position. And I had talked with some people like doing black hole research and other things. But I met Bruce Ballack, who this book is dedicated to, and he was doing work. He was actually an observer doing work on what's called planetary nebula, which are these end states of a star like the sun. But they're the most beautiful objects in the sky, right? They're always the first thing when there's a new telescope that we take pictures of. And I'm a very aesthetic guy, and I've been, really one of the things that drove me into astronomy was the pictures. The pictures of nebula. Nebula always drew my aesthetic love. And so his project was modeling that. Now he couldn't do it because he was an observer, but he had collaborations with fluid dynamicists, astrophysical fluid dynamicists, people who studied gases in space. And so I started working with him and I started learning fluid dynamics, which is such a beautiful theory. I mean, the mathematics behind it's very visual. It's also very technical. And the combination of those, the ability to actually hold in your head an image of this three-dimensional process, and then having the abstract equations. That's what really, it wasn't so much that I was so interested in stellar evolution. It's the fluid dynamics and the theory of it that really grabbed me. So that's where it started.
Yeah, very cool. And your career has taken you to various places, and you're now a professor at University of Rochester. Going through this realm, from physics and this kind of computational kind of realm. You've also now published a lot of articles, kind of on more conceptual ideas in astrobiology in general. How have you seen your own career kind of shifting into this kind of realm where you're kind of now doing all these conceptual things as well?
Well, one can say that tenure means never having to say you're sorry. As you get old, it's not just tenure, but it's as you get older, and you've sort of established yourself in more traditional fields, you kind of have a little bit more freedom to start exploring other domains. Now, I always had an interest in philosophy. So I was a philosophy minor in undergraduate. And the big questions are always what have drawn me. When I first learned about quantum mechanics and its crazy interpretations, that became a huge thing I was interested in. The nature of, I went into physics because of the nature of reality. That's what I was interested in. I wanted to understand what's real, what's truly real, what's there when you're not looking at it. So these other questions, particularly about life, right, and the possibilities of life, fit so cleanly into that idea of the big questions, right? The really what is happening in the universe. So as I got older, and also what was great was astrobiology was not anymore. It wasn't a fringe subject. When I was coming up, there was only SETI, and SETI was still very marginalized. You could not have a career in astronomy starting in SETI, or would have been you were really taking a gamble. So it was just, because astrobiology was exploding, I wanted to find a way in. And so the first project we actually did, I started looking at exoplanet atmospheres. And there was a couple different projects we tried with our code, the fluid dynamics code that we were working with. And the first one, we wanted to look at the atmospheres of Jupiter's, how they, the rotation, the hot Jupiters. And turns out our code was the wrong code for it. But then we found a problem where the exoplanets can lose their atmospheres because of solar radiation. They can just burn them off. And that turns out to be a really important process. So we started doing some papers on that. And that was my entryway into astrobiology. And then finally, I was also doing a lot of popular writing. And it was actually my work with National Public Radio that led me to start looking at astrobiology and the Anthropocene and climate change. It was really struck me that, climate change, we're talking about it wrong. It's really a problem in planetary evolution. And that is what launched that whole stream, which is really what got me into sort of directly doing Techno Signatures and thinking about alien civilizations professionally.
Oh, very cool. I love to remind people when it comes to climate change, a lot of our understanding comes because of space exploration, because of looking at Venus, for instance, and its runaway greenhouse effect, and having Earth-observing satellites, and then finding exoplanets that, are super hot and close to their stars. And so I do love hearing that connection a lot. I do want to talk about your book, The Little Book of Aliens, which I highly recommend. It was a very fun read. This is kind of a book that covers a little bit of everything in the realm of astrobiology, especially kind of the more conceptual topics. And one quote that I wanted to share with the audience from the very beginning of the book, you say that the human species is poised at the edge of its greatest and most important journey. And I love that a lot for where astrobiology is going. It's kind of this realm of like understanding astrobiology, understanding climate change and geoengineering, understanding these large scale things about, back to philosophy. Why are we here? What else is there? What more might happen? We did ask our audience about some important milestones in astrobiology that you speak about in the book in various places, such as, the tree of life and understanding like the Miller-Urey experiment and how life can form, extremophile organisms, hydrothermal vents and possibilities for life in oceans or exoplanet discoveries. Our audience actually said that of all those options, that extremophile organisms were their favorite for the big milestones in astrobiology. But if I had to press you a little bit, what do you think in the last century is like the big milestone for astrobiology in general?
I think it's exoplanet. It's the discovery of exoplanets. Like that changed everything, right? Because if you look at the study, right, the how people went about it, what did we have? Like if prior to 1995 and the first discovery of exoplanets, what did we have? Well, we had SETI, but SETI didn't know where to look and didn't, and had a limited way of looking, right? We didn't, we were pointing, we were kind of doing random searches of stars or looking at sun-like stars and hoping for the best. And then there was the solar system studies, and the solar system was really interesting, but also there were kind of limited possibilities. And then all of a sudden, you end up finding out that every star in the sky hosts a family of worlds. And that 1 in 5, you go out and you count up 5 stars, one of them has a planet orbiting the star in the Goldilocks or habitable zone. And now suddenly, like you had an exponential increase in the possibilities, and then you add onto that the development of atmospheric characterization techniques, where we can actually tell what the atmospheres of these exoplanets are made of, which is mind blowing. That's it. Like that's, the game has changed. Now we can look directly into the atmospheres of exoplanets and tell whether there's chemicals there that could only be put there by life or even technology. So to me, that's the change. That's like, centuries from now, people will look back at that moment and be like, oh, that's when suddenly the field matured.
Yeah, absolutely. Sometimes, people who are like 20 years old right now kind of take for granted that there's always been people in space living beyond the Earth. And someone who's 30 years old might just take for granted that we know of exoplanets. As a young kid, when I was a kid, we didn't know of any at all. And so It's made a big difference. Now, I will say one more quote that I really loved in the book about exoplanets that you shared. In your words, there are places where winds blow through canyons and snow drifts across valleys and waves wash up on shorelines. It's enough to blow open the horizons of your mind. The added possibility that life in all of its creativity might have taken hold on some of them can give you a case of cosmic vertigo. I love that a lot, this concept of cosmic vertigo. Can you expand on that a little bit? What is that feeling that we have as a species?
Well, what I feel is, again, when we think about these planets, to recognize that there are places that you can stand, like, the ones that are terrestrial planets, whether they have an atmosphere or not. And they're, to actually recognize that right now, as you and I are talking, there's all of these other places, other stories. Like, again, the wind blowing down a valley, that's a story. That's something that's happening somewhere. And that there are hundreds of billions of these just in our galaxy alone makes you recognize that your story, with whatever problems, everybody's got problems, but whatever problems you're having or whatever joys, joys and sorrows, that they're just one page in this very big book. I think that's the vertigo, but it's a good vertigo. It's a recognition that, we have a place in the universe, but there's so much more going on that I find that really uplifting in a lot of ways.
Yeah, absolutely. It impacts us a lot just thinking about what's possible and what more might be out there for us as well. Now, we had another poll that we asked through the NASA Astrobiology YouTube channel about some technology that you talk about in the book, these technological kind of innovations and conceptual ideas. So like the Drake equation and Dyson spheres, the Kardashev scale, and maybe other possible large-scale kind of conceptual ideas in astrobiology. And we asked the audience, what is the most intriguing or influential of them? And the Drake equation was easily the most favored by everyone for giving us kind of this way of having a thought experiment about the kinds of civilizations that might be out there. Can you speak a bit to that, the importance of the Drake equation for modern astrobiology and where we're going?
Yeah, it's kind of the foundation in a lot of ways. And what's remarkable about the history of it is that Drake It was an agenda, right? It was actually Drake so Drake does this first study in 1960, the first astrobiology experiment ever. I think people really need to understand that Project Ozma, where Drake basically, he got to use the telescope, the radio telescope, to look at two different stars for signs of extraterrestrial intelligence. So it was the beginning of SETI, Search for Extraterrestrial Intelligence. But that was actually the first astrobiology experiment ever done. The fact that he was looking for intelligent life doesn't take away from the fact that it was the first time we could actually do an observational test for life, right? So people shouldn't lose that fact that was the true beginning of experimental, quote unquote, or observational astrobiology. So the next year, he's asked by the government to host a meeting in interstellar communications. Whoa. And, he puts the meeting together. There's a young Carl Sagan who's going to be attending. And he needs an agenda. Okay, what are we going to talk about for 3 days? And so he breaks the problem. What is the problem? How many technological civilizations are there that we could talk to? And he realizes, okay, I can break this problem up into 7 different pieces, and we'll talk about each subproblem, right? Each subproblem becomes something you can think about. And you can write those subproblems as an equation where it'll equal what each one of those subproblems, the value you'll get will equal the answer to your question, which is how many extraterrestrial intelligence there are. And so there's 7 factors. One is how many stars are there? Next is what fraction of those stars have planets? How many planets are in the habitable zone? Of those planets that are in the habitable zone, how many go on to make intelligence? Then how many form life? How many then go on to intelligence? How many create civilizations? And then the big one for us, how long do their civilizations last? So he basically gave us a way to think about the problem. And when you look at it, what we see is that since he did it, 3 of those terms are nailed down. So that we know how many stars are in the galaxy. They knew that. But what they didn't know is the fraction of stars that had planets and how many planets are in the habitable zone. So we've done, he laid out the course and we've been traveling down it, and we've done pretty well.
Yeah, absolutely. And there's still so much we don't know, like how often does life emerge? How often does life make intelligence? I also agree that last factor, the L factor, is my favorite part of the equation, I think. Given, 1961, we were then becoming very aware of our capability of destroying ourselves. We were still actively testing above ground nuclear weapons regularly at that point. And it feels like sometimes we still face this all the time. We still have nations with many nuclear weapons. We're still seeing warfare across the planet. We're now facing these larger existential threats as well, like climate change and our understanding of where technology may hinder us in the future, as well as benefiting us. And so I do like kind of enjoying thinking about that L factor and what it means for alien civilizations. I will say I had Susan Schneider on the show some years back, and we were talking about this idea of the L factor and how short that lifetime might be for biological civilizations compared to post-biological or machine civilizations. Do you think it's likely, if we do start finding signs of technology out there, that they're more likely to come from post-biological civilizations than biological ones?
I think it's a real possibility. I mean, the whole question of how long the biological era lasts, I sort of have a chapter on that. I do, though, I am very skeptical of the idea that consciousness can be downloaded into computers. We don't understand consciousness. We are not meat computers. That's not my view. So that's the one place I'll have the sticking point. I'm certainly not going to say that machines can't become sentient, because I don't know. But I just want to be a little careful. That whole transhumanist idea that machines will wake up and they will, it's not clear to me that can happen. But I think it's certainly possible, or that just what's left are, what survives, evolution is just our machines, and there'll be no consciousness in them at all. They'll just be kind of zombies, fulfilling tasks, but there's nobody in there, which is kind of the most frightening prospect.
Yeah, absolutely. I will say, so, you have a lot of conceptual ideas in your book, from kind of biological conceptual ideas, Miller-Urey experiment and understanding ocean worlds and things like that, the whole way up to things like the Drake equation and then Dyson spheres, the Kardashev scale. You also do engage a good bit with this concept of, the UFOs, UAP, kind of, are they visiting us now? I will say for myself, I found your approach to be one of the most cogent, sober, and maybe accessible approaches. So for the audience, if you are interested in this topic and you want to kind of explore, a rather unbiased approach to what, has been offered so far, there's a lot of good history in there as well. But you speak about this issue of the giggle factor, as you call it, in the book, that part of the issue with SETI early on getting funding, for instance, was the giggle factor. And we had a lot of issues early on funding a lot of astrobiology relevant research. Can you speak to this? What is the giggle factor?
Well, the giggle factor was very much about linked to UFOs. So I wanted to take on UFOs in the book because, first of all, lots of people are interested in them. If you're talking about aliens, you can't ignore the fact that there's this, people have been talking about them forever. There's this huge culture. And now all since 2017 and those New York Times articles and the Navy videos, that it's just part of the popular consciousness. I am very skeptical that any of this has anything to do with aliens. But, I think you always have to come to science with an agnostic approach. So I'm all for an open, scientific, transparent investigation. And let's see where it leads. But the important thing for astrobiology was, so as I show, the first UFO mass sighting, or the thing that really started it, was in 1947. Already in that story, you can see kind of the wackiness, where like the Kenneth Arnold saw, had this sighting. What he said, what he was seeing were these sort of crescent-shaped things, right? And then there's the most famous misquote in history, where the reporter who's asking him about it misquotes him as saying, "I saw a flying saucer." And then the next day, there's a Chicago Sun article saying supersonic flying saucers seen in over Washington. And within 6 months, the whole world the whole country is seeing flying saucers. He didn't see a flying saucer; he saw a crescent. So you see the whole power of narrative and so the history of UFOs is one of, there's people who are definitely just honestly interested in what's going on, who are skeptical. But there's also this long history of conspiracy theories, unbelievably crappy data, and hoaxes, lots of hoaxes as well. So because of that, anybody who in science wanted to take on the question of life in the universe, particularly intelligent life in the universe, eyebrows would get raised. That Frank Drake, Jill Tarter, they all had to suffer the giggle factor. Like, you brought this up and everyone's like, "Oh, yeah, life in the universe." And you see, actually, as I detail in the book, this actually killed funding for SETI. There were 3 separate times where NASA tried to provide SETI with some funding because NASA was interested. And then somebody in Congress would stand up and say, "We're not going to fund a search for little green men," and literally, put language in the Congress that would stop funding for SETI. So NASA, learned, like, look, we're not going to, this is political dynamite. We're not going to do this again. And so for a long time, the giggle factor basically stopped any funding for the search for particularly intelligent life. I mean, after the exoplanet revolution, you saw astrobiology growing, thank God. That was basically, though, the search for what I call dumb life, right? Microbial life, biospheres. Still, we are the first, I'm the PI, principal investigator of the first grant to do Techno Signatures on exoplanets. And still, I think we're like 1 of 2 or 3 grants. So there still, unfortunately, is some of that giggle factor for Techno Signatures, which makes no sense. Because if half the time, you don't even have to do anything new to look for Techno Signatures. It's just look in the same band that you already have, So I think that's beginning to go away, but there still is, if you just look at the portfolio of grants, it's still overwhelmingly, it's not overwhelming. It's just that there's almost no Techno Signature. So the giggle factor really adversely affected the whole search for life. Still is there but is less so, much less so, for the search for intelligent life.
Yeah, absolutely. And I think we maybe should step back just a moment and maybe explain a bit about technosignatures. We have this realm in astrobiology of looking for biosignatures, these signs, these patterns and structures that are produced by life. And in some cases, people argue a real biosignature has to be only formed by life and not formed in other ways, whereas there's some argument there. But biosignatures are signs of life. And then within biosignatures, we have this realm of technosignatures, signs of technological activity and development that can range from, getting a signal from space from an alien saying hi in whatever language they use, or us actually seeing an alien ship. But there's also a lot of other possible technosignatures. I wonder if you can just briefly for the audience give us kind of a lowdown on what a technosignature is and what it would constitute for us.
Yeah, I would say Techno Signatures is now, for me, that's the name of the field. Like SETI, there was classic SETI, which was great, and there's amazing things still going on in that with like what Breakthrough Listen is doing. That's where you use a radio telescope and you're looking for anomalies or you're looking for actual messages. But what the exoplanet revolution made possible is just looking at planets with civilizations that are going about their business of civilizationing. You don't have to care whether they're trying to contact you. So examples of techno signatures are, say, one of the things that our group did, chlorofluorocarbons, right? This is an industrial chemical, can only be produced by industry, that on Earth got, by mistake was put into the atmosphere. We wrote a paper that showed you could find, with the JWST, with making a few assumptions, you could find the spectral signature of chlorofluorocarbons in a planet that was 40 light years away at Earth levels of chlorofluorocarbons. If you get to 5 or 10 times the level, then it really is a glaring signal. So atmospheric pollutants, whether they were put there by mistake or on purpose, because chlorofluorocarbons are actually a great greenhouse gas. And if you want to warm Mars up, you'd fill it with chlorofluorocarbons. So that's a techno signature, atmospheric chemicals. City lights, there's been a bunch of papers. Thomas Beatty did a nice one that showed that you would be able to see the artificial illumination, the night side artificial illumination, if it's there, from an exoplanet. There's solar panels, any kind, no matter how you build your solar panel, the reflected light would carry a signature in it that you were using solar panels. So those are my 3 most favorite. Another great one, though, that's really cool. Jill Tarter came up with this. If you're looking at a planetary system and you see 4 planets that all have the exact same climate, right? That's a techno signature, right? Because odds are that's not going to happen. That's telling you that, some of those planets, or 3 of them, were terraformed. So these are the kinds of things we're exploring, and that, the field is just opening up. NASA gave us this grant, and, there was the recognition that we were going to be kind of trying to be the tip of the spear on this, to systematize the ideas, to build a library of techno signatures. So it's very real. It's so exciting. I get.
Yeah, I mean, it's so fun to read in your book too about like the evolution of the field. We're getting to this point now where technosignatures is a realm of study of all these different possible things we might see for intelligence out there. Even though we still don't really quite know what intelligence is or what consciousness is, at least we can start looking for things that are relevant to the realms of intelligence and consciousness that we understand ourselves right now. And kind of in that vein, so you've written a number of papers over the years. You've written a lot for Popular Press, but one of your research articles that really stuck out to me was one you co-authored fairly recently with David Grinspoon and Sarah Walker on intelligence as a planetary scale process, which I find really intriguing, especially, again, we don't know exactly what intelligence is. We see it amongst ourselves. We're like, oh yeah, sure, we're intelligent, but then people still argue over whether animals have intelligence, even though you obviously see it with some animals. And so I wonder, can you kind of give us the scope of how would we view intelligence at the planetary scale?
Yeah, so this was, I got to tell you, that was one of the most fun papers I ever wrote. Like just diving into that for 2 years, I was working on it. And the idea was, this came from my work in what I called the astrobiology of the Anthropocene, like trying to understand climate change as a planetary phenomena. Because what we know is we know that the biosphere and the other geospheres, the atmosphere, the hydrosphere, the cryosphere, the lithosphere, they've been co-evolving, right, for billions of years. And the way to put it is that as I like Sarah puts it this way, life didn't happen on Earth, it happened to Earth. And you can say that should be probably for any planet. Life is not some green scruff that just is sort of sitting there on the edge of the planet, nothing else cares. But there's ideas that for a planet to remain inhabited, you have to have life take over in some sense. Life hijacks the evolution of its planet. Now, humanity has developed this thing called a technosphere, right? The sum total of our technology is affecting the planet in the same way that the biosphere is. And that's what climate change is about. And so in this book, what we were looking at was kind of this history of how the Earth evolved. And the question we were asking was whether or not the biosphere, the mature biosphere, like once it had been around long enough to really exert a potent influence on the rest, on the rest of the planet, in terms of hijacking the planet. That is a network of coupled systems, right? A highly complex integrated network of coupled systems. Again, oceans, life, atmosphere. Should that be seen as cognitive in some sense, right? It's just like people have been talking about forests, right? Forests, there's discussion about that. The trees aren't the organism, the forest is the organism because of the connection between the roots. The roots all have these fungal connections. There's indications that if part of the forest is undergoing stress, the rest of the trees will send nutrients to that part of the forest, as if there was a slow thinking green mind, right? Metaphorically, right? Should we think of, and we also have there's a lot of discussion now, but distributed intelligence, right? That the idea of our kinds of brains are just one way of having intelligence. Ant colonies are distributed intelligence. Slime molds can solve mazes, right? So we're just recognizing that there's solid brains like we have, and there's liquid brains. And that maybe the whole biosphere should be seen as a kind of, in the Gaian theory, there's Gaia theory, which says that, the Earth is a kind of, the Earth has exerted influences on the planet to maintain its own existence. And so maybe we should see the biosphere as a kind of distributed cognitive structure that helps maintain the planet in its, in a state that is good for itself. And the technosphere, right? The problem right now we have a technosphere, but it's an immature technosphere, which is destroying itself. It's destroying the conditions that it needs to maintain. And so the next step, just like the biosphere, would be to become a mature technosphere that supports its own conditions for its longevity. So that's the whole idea of planetary intelligence, was maybe the biosphere exhibits these properties of planetary intelligence, and we need to figure out how to make the technosphere have the same.
I love it. Yeah. It very much reminds me of Olaf Stapledon's Star Maker and this idea of these conscious worlds and things like that. Such cool stuff to talk about, Adam. I could talk with you for hours myself, but we do have other segments of the show, including, our Q&A for our audience who can ask questions right now in the YouTube chat live. But first, we have our Faster Than Light segment, so our short answer segment. Okay. And it's kind of fun just to ask a few really simple questions we ask everyone, and we just like to see this variety of the different answers we get from everyone. The first one speaks actually to you very well and your new book. What is your favorite answer to Fermi's question, where are they?
Yeah, my favorite answer to the Fermi paradox is that there is no Fermi paradox. And I want to be very clear about that, because there's two Fermi paradoxes. The first one is, why aren't they here now? But the other one is, we've listened and we haven't heard anything, the great silence. And my answer to that is, we really haven't listened. SETI, there's just never been any money for SETI. So we just really haven't started to search, but now finally we are.
Awesome. Yeah, I agree entirely. We really haven't even looked yet. It's just a little bit of looking we've done so far. We've barely started. Now, in the book, I'll say, as a nerd myself for all kinds of things in culture and sci-fi and that kind of stuff, you have references, allusion quotes from The Big Lebowski and Dune, Hitchhiker's Guide, from video games. I mean, there's a bunch of stuff in here for those who are nerdy like we are, I would say. But what would you say? What are the stories that have inspired you the most to want to explore life in the universe?
Well, first of all, as a kid, it's Star Trek, the original series Star Trek. Kirk is my captain. I mean, I love the other captains, but Kirk was my captain because it was on endlessly when I was growing up in the 70s on replay. So I've seen every episode, I don't know, probably 100 times at least. But more recently, The Expanse, the books and the TV show, I can't recommend it enough. As I've written in a couple places, it is the greatest science fiction show ever made. And I stand by that. Really rich understanding of what a settled solar system, what the next 300 years, 500 years will look like for humanity. And then really interesting ideas about alien life and alien intelligence and what it can do.
Yeah, fantastic. Yeah, I love the Expanse series so much. I had a chance with Ty and Daniel to watch the movie Alien once together with them and hear their perspective of this idea of the Expanse really was focusing on the blue collar workers to start off with, and kind of exploring, their relationship to this, world, this universe changing phenomenon. Yeah. So for my next question, if you could go back in time to the beginning of your career and give yourself some advice, what would you say?
Chill out, dude. Basically, as I explained, there was nothing in my life that I could do except be an astronomer. Some people will need to be a dancer or a poet, or there was nothing else I wanted to do but be an astrophysicist. And I worked so tirelessly. And, of course you have to be an astronomer. It's really hard work. But I wish I could have, if I could go back and to be like, yo, man, it's going to be okay. Like you can work like maybe like 5% less and use some of that time to take a walk or something. That's what I would tell myself, or just have a little bit less anxiety about whether or not this is going to work out.
Awesome. Love it. So, we've done a lot in astrobiology already. There's been, these huge milestones we've had from understanding the potential for life on Mars or even in Venus's atmosphere, on the ocean worlds, but also all of these exoplanets. So if there is alien life out there, do you think we're likely to find it first in our own solar system or on an exoplanet far away?
Yeah, that's a really hard question because they're both really interesting and they're both held a lot of possibilities. On the solar system side, you've got the fact that, we're going to be landing on Mars soon, digging in the soil, looking for either existent organisms or the possibilities of evidence for previous organisms. We've got all these ocean worlds, which are mind blowing, and we don't, what's possible at the bottom of those or in those oceans. But I still think, if I had to put money down, it's just the number of exoplanets and the number of possibilities. I think we're going to find some kind of evidence for life, some kind of bio or techno signature before we get really what we need from the solar system. That's just a bet, but I don't know.
Awesome. So what is something that excites you about the future?
I think the most important thing I'm looking forward to is the settlement of the solar system. I really think, if we can, as I like to say, the solar system is the prize we win if we get through climate change and all the other ridiculous things that we're going through right now. If we can manage to, get through the wheels coming off the bus right now, then the next 500, 1,000 years, what are we going to do? We're going to settle every nook and cranny in the solar system, and it's going to be amazing. The experiments in democracy, in different kinds of thriving human communities that are possible out there, I think are going to be remarkable. So that's what I'm really excited about.
Awesome. This next question is my favorite of them all. It's the last question in our Faster Than Light segment. What is an unbelievable science fact that still blows your mind?
It is the fact that inside every one of your cells, you have little molecular machines that are climbing ladders, literally, protein ladders, and moving. They're like tow trucks, and they move along those ladders, and they carry big blobs of, ATP with them. I think they're called actin machines, and they're just, you can find videos of them. They are the most extraordinary molecular devices, and they're inside of every one of your cells. The ability of life to innovate on a molecular level, which is why any of us are here, I think is just, it's hard not to be in awe of it.
Yeah, we are incredible universes in and of ourselves, right? It's all this incredible stuff going on inside of our bodies. I do find it interesting that often when I have biologists on the show, they love to remark about something out there in the cosmos, and I have an astrophysicist on the show talking about biology. It's kind of this intriguing, thing, just unfolding all these things we understand about ourselves. Now, before I go to the audience Q&A, I do just have to ask for my own personal interest. You were the science advisor on the Marvel movie Doctor Strange. Can you just tell us what that was like and what kind of science you were advising on for the show?
Yeah, as I like to say, best day ever. So I've been a Marvel fan forever. Like I was, as a kid, I was a huge Marvel fan. And so I was always really into it. And then what happened was the director, Scott Derrickson, who's an amazing guy, really, he directs, he's known for making these incredible horror movies, or, that's his genre, but he also has a deep interest in religion or spirituality and science. And my first book was about science and human spirituality. And it was through that somebody, we got in contact, and we've been having an interesting conversation about it, since then. And when he was tapped to be the director, he contacted me and said, I would like to suggest, to Marvel that you be the science consultant. I was like, okay. And then nothing, I didn't hear from him for a while. And then I got an email, I'll never forget, that said, Marvel wants to talk to you. I was like, ah. So, what happened is they gave me the script, super secret, right? Like I had to sign my life away that I wouldn't. And then they flew me out there, and I spent a day with Scott and John Spates, and even Kevin Feige came in, working through they had a couple of particular questions they wanted help with. Like one was, there's that amazing scene when Doctor Strange meets the Ancient One. And, at first he's super skeptical. She shows him, these different maps of the human body. One is like, an fMRI. The next one is like chakras. And he's being, all sort of like smarmy and like, yeah, I don't believe in that. And they wanted to know, what would he say? Like, what would a scientist's reaction to this be? And some of that dialogue straight on went into the movie, which was awesome. And then they were also this was the beginning of the Marvel multiverse, right? That was the first movie that had the now dominant Marvel. So we talked a lot about the multiverse and how that figures. And I'm not a big fan of the multiverse. I think it's fiction, basically. But still, we had lots of ideas about how it would work. So it was just so exciting. And the best part was, at some point, Kevin Feige comes in. This guy's responsible for $80 billion of movies. And I shook his hand and said, "Hey, man, I'm a fan." I said, "I'm also a huge fan of Marvel." And he said, "What's your favorite comic?" And because I'm such a nerd, I could do the deep dive. There's like an issue of Star-Lord from 1978. Before Star-Lord it was a special edition. And I named that one. He was like, "Oh, yeah." I was like, "Yeah, that's right, baby. Super nerd here. That's right."
I love it. That's fantastic. Yeah, I think many of us, who pursued careers in the sciences were also inspired by, a lot of these kinds of stories growing up from comic books and like video games, and so a lot of us would love that experience of just having a chance to have some input on how to bring the science to these fun science fiction kind of ideas. So thank you so much for talking with me. But now it's time for some Q&A with our audience. So they'll ask me questions and I'll bring them to you. First off is one that came in the other day from LinkedIn from a colleague of mine, Stephen Paulaway, who he's really into space. He loves talking to me about it. He said he finds it awe-inspiring and fascinating. But he also feels like there might be little interest for exploring space and understanding about space amongst the average person. And he wants to know maybe what your perspective on why that might be. Is it about fear or feeling insignificant? Why does it seem like most people don't actually seem that invested?
Well, I think, that's one of the reasons why aliens are so great. Because as the first line of my book says, everybody loves aliens. Like, there's almost nobody who is not interested in the possibility of life in the universe. Now, normally that's going to be associated with UFOs and UAPs, but it's a great door opener to get people interested in, the broader topics. The thing is, I think most people are living their lives, right? And they're concerned with the immediate, with just getting through the day. And I think, the job for like what you're doing, and the job of those who are also are scientists and do science communication is to show people that actually this is part of their lives. This is actually part, and it can be, as we talked about in the beginning, it's actually something that there's a spiritual component, if for lack of a better word. It opens your eyes. It broadens your horizons. It shows you that your little story is part of something much broader. And I think that's the story that we need to show to people. The problem is often science is presented as being this dry bunch of facts, like a giant that's just picking up facts. And we need to show people much more that it's a narrative. It's a narrative about how the world is constructed, and it's their world. So, good question.
Yeah, absolutely. And taking part in our world is very important for all of us. We have a question from, I might mispronounce this and I apologize. It's Adaberg Karatosh on YouTube. Adaberg wants to know if it's possible to detect organic molecules in exoplanets through light refraction, like photospectroscopy. Could this work like a biosensor? I'm guessing that they're kind of asking, with the light going through the exoplanet atmosphere, if we can find organic molecules currently.
Yeah, sure. Methane. I mean, when you say organic, I mean, methane is organic chemistry, right? So we found methane. So what was it? K28-18b, which is this really cool new class of habitable planets called a Hycean world. And it's that means hydrogen ocean. It's an entirely different kind of world. It's like 8 times the mass of Earth. But they found like clear methane. The methane signal was what we call 5 sigma, which means absolutely they found it. So yes. And so if you're asking about molecules that are associated with organic life, depending on what the molecule is, yeah, we should be able to find that as well. Like the possibilities of finding dimethyl sulfide, which is the what plankton in our atmosphere, pardon my language, fart into the atmosphere. That's a real possibility that we'll be looking for. So definitely we have the possibility for finding chemistry associated with life in alien atmospheres.
Very interesting. A question coming in from Manisha Pahari. they're asking about if we can find or detect life like prokaryote or like a bacteria living on an exoplanet, compared to looking for techno signatures. And I guess that really does go to looking at exoplanet atmospheres to see if we can find evidence of a biosphere. Do you think it's even likely that we'll find evidence of maybe a less developed or at least early stages of evolution type of biosphere, especially if it's not interacting greatly with its atmosphere?
Well, that's the problem. You've got to get it to interact with the you've got it. Like, so remember, we were just talking before about like an immature biosphere and a mature biosphere. A mature biosphere is when those feedback loops, the co-evolution kicks in, because that's when the biosphere is changing, say, the atmosphere. But that should happen pretty quickly. Like you look at Earth's history, and there were biosignatures kicking in pretty quickly. Certainly after 1 billion years or so of evolution. So I think the possibility of seeing how microbes and mass affect a planet in a way that would be detectable, I think Earth's history gives us really good evidence that should happen pretty quickly, and there will be detectable consequences.
Absolutely. There's a question here from Anne Sophie on YouTube who asks about the mineralogy of stars in searching for possible planets. They say, so looking at what minerals are found in stars and therefore maybe in planets. I want to start off there, Annie, or Anne Sophie, and just say with stars, there's so much energy, so much pressure happening in these stars. There actually aren't minerals inside of the stars. Everything's actually kind of separated into the elements within the stars, the fuel, the hydrogen, the helium, inside some larger elements as well that are being fused together through this process of nuclear fusion. And so we're not really looking for minerals on stars. But there is an interesting kind of idea, and I think I'll switch to that Robert Hazen and some others at Carnegie and some other places have been discussing lately, looking at mineral evolution of planets. And that maybe in a biological world, one that has a biosphere like ours, we see this huge jump in the number of minerals available at the surface of the world. And so, Adam, for you, let's speculate a little bit. Do you think technological development itself will produce even another jump, perhaps, in the minerals that we might be able to find in a world, or maybe even potentially detect as solid structures in an atmosphere one day?
That's an interesting question. But, before we go there, I do want to note there is this connection between the metals, right? There's no minerals in a star, but it does seem like stars that have heavy metal, what we call metals. Now in astronomy, a metal is anything heavier than helium. So, but that in general, we do see a connection between having heavier elements in the star, in its traces, just in its the elements floating around in the atmosphere, and the existence of planets. So there is at least that connection. But I definitely think that you're absolutely right. A technosphere will probably reshape the planet's the components of the planet, certainly the surface components of the planet, in ways that might even be detectable, especially if you look at glint. When we think about reflectivity, right? So one way glint is this idea that you should be able to see the reflection of oceans on exoplanets and be able to pick that up. And so maybe in some ways, if you are doing one idea that we're working on, so a little back step, is something that we are working on a paper now, the idea of service worlds, right? That if you're in a solar system, you're living on your planet, but you got all these other planets that are uninhabitable. Maybe that's where you put your industry, right? And so it's a service world. So you do, maybe you you glaze over the atmosphere or the surface of a planet and have wires attached to it so that the whole thing becomes a solar collector, right? So service worlds might have very different mineralogy because we've done it on purpose for that, and that would be detectable from a distance. So yeah, I think that's a real possibility.
No, that's very cool. So in our discussion here already, we've discussed the possibility for using CFCs to terraform Mars. And so we have worlds where we're changing their climate, but then there could also be worlds that are used specifically just for servicing, for resources for another world, like appendages of those planetary intelligences, reaching out and adding in more. I love that idea. And you're right. I do think it's important that we remember that those more metal-rich stars in the astronomical sense are more likely to have, more variety in the kinds of planets they might form in their star systems. And so it's worth considering. We have a question coming in from one of our production assistants who I don't think she can help herself because she's also a fan of The Expanse, and so am I. And amongst a lot of us interested in space exploration, there's often this discussion of the Star Trek future versus the Expanse future, kind of almost as a dichotomy, because in the Expanse there's cultural butting of heads. There's almost an ethnic battle between the Martians and the humans from Earth and those out in the belt. And then in Star Trek, you kind of have more like this very socialist kind of future. There's no money. There's just seeking progress together as a species, but there still are philosophical issues. And so I think Sarah wants to know, what are your hopes for our future kind of in these realms of Star Trek and The Expanse?
Well, I think, I am hopeful because what's the alternative? But I do think, like I said, I think climate change is ultimately going to force us to come up to have to, you don't evolve unless there's a gun to your head, right? You need evolutionary pressure. I think ultimately the stress from climate change is going to force us to change our understanding of how we structure society. Things have got to change. As I say, the wheels are coming off the bus. It's pretty obvious. So there's a next step. And I think that next step, as I said, will be the expansion into the solar system. And one of the things I love about that is the idea. We wrote a paper about how you could turn asteroids into space cities. Like, the idea came from, I wanted to see whether or not the idea in The Expanse worked. So can you spin up an asteroid, hollow out an asteroid and spin it up? Turns out you can't because it'll break apart. But then we came up with another idea about how actually to use that to make a space city. And I could imagine that there could be thousands of these space cities, each having millions of people, and each one could be an experiment, right? They're far enough apart that, sure, I'm sure there's going to be a Mormon space city, right? And maybe you want a space city that is only some kind of free socialist collective. And you have another one that's just a libertarian paradise or an attempt at a libertarian. And I just think space is going to offer us the capacity to really carry out experiments in human thriving that wouldn't be possible if we're all just stuck on the planet.
Yeah, it's a very cool idea. Just thinking about what's possible for the great diversity of humans moving to different places and diversifying very greatly, and what evolution might do in the long term.
Yeah,
both biological evolution and technological evolution when you have those different experiments running. We do have an anonymous question that came in concerning current NASA missions, future NASA missions. Are there any that you find the most exciting for your current or maybe even future work?
Well, I mean, the big daddy is the Habitable Worlds Observatory, right? So the what will follow the James Webb Space Telescope is the Habitable Worlds Observatory. It's 20 years, out, right? Because it takes that long to build one of these things. But the excitement is in the name, right? That tells you right there. What's amazing is that, I'm old enough to remember when astrobiology was still, there was no astrobiology, right? There were no departments or grants, really. It was just, there was this minor little thin thing happening. And so now what the Habitable Worlds Observatory shows is that the entire astronomical community is all in. Like, this is seen as being the most important problem, or one of the most important problems for astronomers to solve. So that in itself shows you, where we're at. Now, there's other missions like, the missions to the ocean moons, Titan. I think those are all really exciting. But, it's really the idea that the Habitable Worlds Observatory is finally going to give us the kind of technology we need to really find biosignatures.
Very cool. Yeah, I love Europa Clipper. I love Dragonfly and all the things that we're doing in the solar system. We need to get back to Venus personally and get a bunch more missions there, and a flagship mission even out to Uranus and also Neptune both. I think they both need flagship missions.
Sure.
But there's so much more we can do. But yeah, like these telescopes are really unlocking so much more of the universe for us with James Webb Space Telescope, this Habitable World Observatory that might be coming up in the future. One question from another one of our production assistants, Mariam Nassim, wants to know, what are the real challenges right now then that we can perceive in Techno Signature research, and maybe how well equipped are our current or future telescopes for finding Techno Signatures?
Well, I think this is what's true for both bio and techno signatures, or false positives, right? I mean, as Sarah Walker says, a molecule is not a biosignature, right? It's you need to understand the context of the world. You need to take that signature, and is it likely that this is the kind of world that is going to have what you need for life? So, in these early phases of the search, our data is going to be, so-so. It's going to be we're always going to be on the edge, at least for the next, 10, 20 years of having the kind of data we want. So it's going to be the interpretation and making sure we're not being fooled. That is going to be the major challenge. But we're getting better all the time. I mean, there's a lot of smart people applying their smarts to this problem. And just in the last few years, watching the progress in both the biosignature and techno signature community has been pretty stunning.
Awesome. We have one more question coming in. I think we'll end it with that question then, from Flagellum 9 Day. They like the Mars Trilogy, Kim Stanley Robinson's Mars Trilogy, more than The Expanse. And they want to know if you have any opinion on that vision of technology and our future.
I would also agree that I could easily put the Mars Trilogy above The Expanse, because I also love it. I got a chance to go hiking with Kim Stanley Robinson, which was also
Very
best
cool.
day ever. What an amazing guy. I love the Mars Trilogy and it's clear that The Expanse comes from the Mars Trilogy, right? It's it's that kind of vision because it's a story of the settlement of the solar system. And really, Kim Stanley Robinson in the 80s, when he started writing that was the era of cyberpunk. Nobody was doing what he was doing. And so he was the one who almost single-handedly got a science fiction to turn back to the solar system and start asking questions about what would an inhabited solar system look like. So I think his vision of the future is very exciting and very interesting. Obviously, he was accelerating the timescale for terraforming, but I think he was the pioneer of imagining what a settled solar system could look like.
Yeah, absolutely. And a lot of his later work has been focused on climate change and what our very near future of our civilization and mid near future of our civilization might look like. So, Adam, thank you so much for talking with us here on Ask an Astrobiologist, sharing your thoughts. Everyone go out and buy The Little Book of Aliens by Dr. Adam Frank. Thank you for joining us.
It was a real pleasure. Thank you, Graham.
Yeah, and for all of those watching, if you want to learn more about Dr. Frank, all of his work, find some of his publications, both research articles, the various things he's written for a lot of different news outlets, including his own blog on Big Think, the 13.8 blog, you can find it at adamfrankscience.com. That's adamfrankscience.com. And if you want to know more about the NASA Astrobiology program and what we're doing for our show, for events in astrobiology, opportunities for students, graduate students, researchers in astrobiology, there's a whole bunch of things we share through that mailing list. So feel free to sign up there. For Dr. Adam Frank, thank you so much. For our audience tuning in, thank you so much for joining us. And until next time, everyone, stay curious.